Hi, and welcome to F-Sharp Tutorials. Today we are going to talk about how to declare and use reference variables and types in F-Sharp. I will start by showing some simpler demonstrations on how references in F-Sharp work. Then I will show some more complicated applications and elaborate on when and why you should use them. Before you watch this video, I assume that you have experience with programming in general and that you have a basic understanding of how F-Sharp works. So let's get started. Now the first example I want to show is not too complicated because this is to just kind of show when references are really needed. So let's assume that I have a basic integer that main equals, so this is some main function that I will be calling later on. In this main function I will indent using spaces because that's F-Sharp. Okay, I am going to declare a value. Let's call it a and set it to 5 because that's an easy number to work with. Then I want to have an external function called add1. I'll just be calling this with a, and add1 should take a and, well, add 1, so this should be 6, and then afterwards I am going to print it out, printfn a, and that is the simplicity of this program. Up here I declare add1, this accepts a number, and this number should equal number plus 1. So that's it, pretty simple. The structure of the program, basically how I want it to work. And to compile it, I am using the Mono compiler. I guess you could go with the Microsoft Visual Studio, but this works fine for me. So F-Sharp compiler, I've just called this 1.fsx. And now I get a compiler warning. It says this expression should have type unit but has type bool. What is going on here? So of course the first thing we notice is that this is F-Sharp, and this is quite a rookie mistake. In F-Sharp this is not how you set something to be something. Now this is just testing, is number equal to number of plus 1, which is of course ridiculous. Okay, so I want to use this operator. Now this should assign this expression to the number. Great, try again. And no, quite not, still there. This number is not mutable. Aha, but I could use mutable here because now a is mutable, right? And when I call this add1 with a, it knows that a is a mutable value and there should be no problem. So we go again, and it's still not quite is how I want it to be. So the point here is that there's something in F-Sharp called inferring, and it goes through this function and sees, okay, it accepts some kind of input. When is this input used? Oh, it does not know what this is. It goes up here and says, well, it's plus 1. 1 is an integer, so number must be an integer too. So it's like this, but I don't really need to use it for standard because F-Sharp knows it. But in this case, this is what happens. So that's not good. I want it to be mutable, but F-Sharp will not allow me to write mutable in this way. Instead, what I need here is a reference, because this a is declared in the scope here. And then I call it add1. It's fine, here it knows what a is. But when I go up here, we are out of scope and a does not exist unless I specifically tell the compiler that it should use this value. So what I want to do is use what is called a reference, which is what this video is all about. So I am going to write int ref, and then it's a reference, magic. And there's some differences in syntax, of course. I'm not going to use this operator, I'm going to use referencing assignment operator. It looks like this, kind of crazy. And to access it, I need to use this, which is called the bang operator. By the way, bang is spelled like B-A-N-G, bang. Okay, so this is the function. It accesses what number is, and then it adds 1. And then it assigns this expression to number. Now, this is all just fine, but in here, in main, a is still just a mutable value. There's a difference between a mutable value and a reference value, or the more precise term is actually reference cell. Well, the difference is how it is stored in the memory. And I can write it like this. Mutable a is stored on the stack for more technical people. Now, what I really need when I'm working with references is I want it to be stored on the heap. Now, how do I do this? Well, first of all, I remove a mutable, and then I declare it as a reference value. And there's that. So now, basically, what this means is that we have the number of 5. It's an integer. We declare something to be referencing this number, and then we have the reference saved in the value of a. So each time when we use a, we are meaning the reference that is used to store this variable, 5. However, when I print a out here, I'm not going to get the number 5 or the number 6 after it has been increased. I'm going to access the actual reference variable, the reference from where it is stored, and if I do like this, we can see it explicitly what is actually going on. Compile and mono exit, and we see this is contents equals 6. So the number 6, that's correct. I'm getting this because this works just fine, and I'm increasing it, and I don't need to save it because this is saving it, and that's perfect. But it's a record. I don't want a record, I want to access this number. This is just how F# works with references. Okay, so I can access it via this bang operator. And that's how I access it. Perfect, I get the number of 6, so it has worked correctly. There are different ways that you can do this. You could also say a.value, and just to showcase that there are different ways of doing this, you could say a.contents, and then last bang a. Different ways of accessing referenced variables, and they all work the same way. Okay, so great success. Now we have a variable a that is declared in a local scope, and we can actually access it outside of this scope by using referencing. That is pretty smart. Okay, so this reference is stored on the heap, and there is, however, an alternative way if you want it to be stored on the stack, however, and that is called by reference. Not reference, but by reference. So, and the idea is that, as before, we declare this as a mutable variable, and up here we want to use the standard way of assigning mutable variables. And instead of reference, we write by reference. And this is the same as before, this won't be enough because F# will interpret it as being an int, and it's not an int, it's actually an int by reference. Okay, and the way I call it with the function is by doing this. This ampersand is standard in some programming languages, at least C++ as far as I know. But that's how we do it in F#. And I will try to compile it, and you can see, as before, we get the number 6. This is perfect. And I suppose I could be more explicit. Let's say I want to use a for loop for I equal 1 to some 15, I think will do. And try to clean this up a bit. We see 6, 7, 8, 9, 10, blah blah blah, all the way to 20. That's perfect. So by references, well, theoretically they are different from using references, but in this case they work the same way. So it's just to, well, showing that there are different ways of achieving things, which is a good thing. Okay, so I've prepared some other examples. These are programs that I have already written, and I will just walk through of how I did it. So, this one, yeah. Okay, so in this program, I have a record, and a record here is of type box, and it has some width and length and height. Then I have a function that's called redefine box. Now this function accepts a box by reference and some 3 measurements, which should be floating point values as they are up here, and then it will create a new record and well, reassign B, the box, to be this new record instead of the old one. And then I have the function calculate area, which will calculate the area of the box by accessing width, length and height. And there are some small mistakes in this program that I need to correct before I can run it. First of all, box should be a by reference, as we have up here. It is mutable, that's fine. And I believe that's it. Oh, I should be calling with the ampersands. Okay. Now, I have some centimeters here, and it's just because I thought it would be nice to have them in this program. I declare it like this. I write measure and then the name of the type, centimeters. And this could be very useful if you're writing a big application that, say, you do some complicated calculations on some physics experiment, and let's say you don't want to mix inches with centimeters, or some part of the programming is calculating in Kelvin and some other part is doing in Fahrenheit, and you really want the results to be correct. So this is how you can be sure that they will always be correct. And in F# this works this way. For example, when I call the calc array function, b width times b length times b height, this is actually saying, okay, the result should be centimeter to the power 3. So that's how this works. It's pretty neat. Okay, let's run the program and see if I have done everything correctly. F# compiler for... it's in a different folder, sorry about that. I'll go to show folder, F# compiler for the FSX. And I have an error, which is probably here. Let's try again. Perfect. It compiles, so it should be ready to go. Yes. So what happens here is that I declare it with these measurements, and then I call the printfn for the calculate area, and it returns 61.25 as you see here. Then I use the redefine function, which I have up here, and I store a different record onto the variable b, which is really the sandbox. So it's a useful application of using references, and as you see, the returned result is actually now 90, so it works. So I could be doing this instead of by references with references, and I'll just showcase this. So I would need to use the bang operator all these places, and well, I could write value here for using different ways of getting the same results, contents, and of course up here too. I need to use this operator instead. Okay, and remove this, and instead accessing the object. No, that should be fine. I might have forgotten something, but we'll see. Yeah, I need to write reference here. Yeah, so that is the other way of referencing. One is stored on the heap, which is this one, reference, and the other one is stored on the stack. And again, if you're a technical kind of person who really wants to use that difference, if it's necessary in an application, these are what the differences are. But in a simpler example like this, you can use both. It doesn't really matter. Great. So the next example is example 2, I believe. Yeah. So I have made a little more complicated program here. I will go through the code to explain what it does first, and then afterwards I will compile it and run it so you can see the results, and then I will of course explain where I'm using all these references. Great. So first off, I'm using some .NET libraries containing forms, colors, and brushes because I thought I wanted to use references to actually draw an image. So I have system.drawing and system.windows.forms. I start by declaring my own color type, which is of 3 times int, and then I have a function here, color to RGB, which does exactly what the title of it says. It matches an input color of my own predefined type and returns an RGB color from that. Okay, and then I have my custom class, which is my own sort of fancy wrapper for the standard 2D array. Now, I am checking if it gets a palette that is empty, and the palette should be a list of colors as defined up here, and because, well, this 2D array class will be used to draw an image based on the colors found in this list, and if there are no colors it cannot be drawn. So I'm making a random object, and I am getting how many colors there are. Then I'm using this getColor function, which indexes randomly, and then I have this array, array2d.init, where I take a color and returns an RGB. So basically this 2D array will contain random colors based on the colors that I get from this list, and they will be placed randomly. Then I have some properties array. This is the actual array containing the RGB colors. It has width and it has height. Okay, great. draw function, it receives a form, which is basically a program window. It is a table, which is this custom type of color table that I declared up here. It's a reference, and then I have a size. Okay, I'm using some T here, color 2D. This means 2D array, by the way. Reference, and it's just my own shortcut to access it without using the bang operator and write table and dot array. So this is just T. I thought it would be faster. Then I'm making a brush because I need brushes to color the window. Then I have this function that iterates a double for loop, and then it fills a rectangle of the type brush and a rectangle of the size that is specified as input of the function. Then I define some color schemes, some brown and pink and blue and gray and binary and pizza colors because I like pizza. Okay, I need some more info because before this program can run, I need some X and Y and pixel size. So basically this is how many blocks of color, how many squares do I want down the x-axis, and how many up the y-axis. I'm using square in this because these are equal. It could be rectangles. The pixel size 50 for each, so they will not look too small. Then I am creating a new color table with X and Y, and this list of pizza colors, which should be colors of the Italian flag, green and white and red. I'm declared as a new object, and then I am referencing it by the name A. Then the window size, it is a size from the system, and then I create my window. Client size equals window size. It's something crazy that you need so the picture will fit in the correct size. And then the title of it, color rectangles, version 1.0, and maximize box and minimize box. These are not really necessary. It's like we have up here, if I can minimize Sublime Text or maximize it. So the fun comes here. I'm calling the draw function. I'm using a by reference to the mutable window, and window needs to be mutable, else it won't work. With A, which is a reference stored on the heap, which means when I use A up here in the draw function, I will need to bang it. No funny jokes intended. And then I'm using the windows that show, else it won't show as a window when I run the program. Kind of silly, but that's how it works. And then I have some application that will run with this window. So let's compile it and see how it looks like. F#C example2.fsx. And it compiles great. So this is the program. This is the window. There are some nice colors here, and they are generated randomly, and I'm using referencing to be used in this draw function. Now I can do it again up here, and I will get a different results. So the randomizing works perfectly. And I could say I don't want the pizza colors, I want the blue colors, because they're kind of nice. So you see, now they are blue. So I can make a list of how many colors I want, and it all works. So the real point is here using the references. And this is where it gets really funny. If you come from another programming language, say C++, if you do not call these as references, then when you call the function from down here, the compiler will actually create a new copy of window and a new copy of the table A and modify these. And when you get back the original window and A will not be modified, because they will be modified in a local scope somewhere else, and then when that scope is exited, the changes will be lost. But this is where F# really shines, I guess, because it makes the syntax so much more simple. I could really, if I didn't want to, I could avoid using by reference here, and I could remove it from here, and I do not even need to declare it as mutable because it is system .NET object, so it is mutable by definition. Okay, and I will compile it, and you will see that the compiler does not complain and the window is still generated. So what is going on here? And I could also do it with this and remove reference from here and from here, and remove this and here and here, and remove this dot value, and I believe that should work for now. Of course, this will be kind of not so smart here. I'm just copying the array here from the color table, creating a new copy of it, and then using that. It's not really necessary, but I will keep it because, yeah, you know. And this reference will also. So that's how it is. I believe I got everything. We'll see. And the program still generates the window. So this is how F# really wants to be. It wants to keep the syntax as clean as possible, and in some cases you really do need to use these references, as we saw in the example in the start of the video, by using the integers. And it's the same when you're using floating point values or booleans or strings. So these kind of basic data structures, they need referencing if you're using them outside of scope. But in F# it's not really necessary, and this accounts for all objects and even records, as I used in the previous example. So I have one last example to show you, and this is a case where it really does matter if you use referencing or not. So, and this I believe, yeah. So this is something that F# calls partial application. And I'm using some kind of little game to show how this actually works. So I have a spaceship here, and it fires a devastating blast. It is really the great fear of the galaxy. It has two weapons, a Gatling laser and a pulse cannon, because that was what I could come up with, and I thought, yeah, that would be pretty good for a spaceship, right? Then the powerful Gatling laser is mutable here, and it deals a damage of 4,500. And I will, by the way, skip these for now. Then I'm getting ready to launch. I'm declaring a shoot method. Please notice that this is not a function, because there's not this unit. It's called partial application because it is a variable stored, but it does need a little bit more to actually be used. So it should receive an input. The type of this shoot is really accepting an integer and returning an integer by calling this spaceship1 function up here. The Gatling laser is this integer value, mutable of 4,500, and this accepts a 4,500 and something else. Great. So now I'm overwriting Gatling laser 1 with 8,500. So now it should be dealing more damage. And then I can shoot it with 10,000, so it will return 18,500 as damage. Okay, that's one part of the program. I will explain the other things before I try to compile, and we'll see what happens. So the other one is Spaceship 2, it is the same as before, except I'm using the bang operator here. So that really tells me that this is a reference. So it's not an integer, it's a reference to an integer. And it's defined up here. Gatling laser 2 equals ref 3700. That's the same as before. And then I have a shoot method to use this Spaceship 2 and the Gatling laser 2. Of course the pulse cannon is also. Yeah. Then I'm upgrading the Gatling laser, the 1 and the 2. And I use this special reference assignment operator to really get the value of 6700 instead of this value, because I thought this would be a kind of weak Gatling laser, so I want to upgrade it. And as with the first spaceship, second spaceship should also have a shoot. Okay, so we'll see what happens. F# compiler, example 3. So no warnings or errors, that's fine. So as we see, spaceship fires with Gatling laser 1 deals, and what? 14,500, but I reassigned it here, right? Well, this is where partial application really speaks its mind. It doesn't care that I reassign it here, because this one is not a reference. So if I would be using a reference here, like I do here, I'm really telling the shoot to not using an actual value, but using a reference to a value, which means that even though this is partially applicated with this one, this is not a concrete value, and this can change actually. So that is an example where using references is actually necessary, because as we see, the other one, Spaceship fires with Gatling laser 2, it deals 16,700, and that's exactly what I did here when I reassigned it, plus 10,000. So that was what I could come up with regarding to references in F# and how they work. I hope this video helped you. If you have a comment, or if there's a particular topic you would like to see a tutorial on, write it in the comments below, and I will see you next time.